This is Sudheer, working as an assistant professor in Department of Civil Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. I welcome all the students for a series of fluid mechanics course which is to be delivered through these video presentations. Now, through these video presentations, I would like to deliver the topics that are being covered in the fluid mechanics course which are helpful for the students. I am going to discuss about the basic concepts of the fluid mechanics, that says like the introduction and properties that are basically useful for the fluid mechanics part. So in this case, generally we see the definition of the fluid mechanics is the branch of the science which deals with the behavior of the liquid particles or gaseous particles which are either at the rest position or under moving condition. So that is called the fluid mechanics part. So if the fluid part is at the rest position, then it is called as a fluid statics, and if it is at the moving position, then it may be called as fluid dynamics or fluid kinematics. So the fluid, again, when the liquid is at the moving position, it may be considered into two categories, without considering the force or with the consideration of the force. So the behavior of the liquid particles under the moving condition, the analysis part is known as fluid kinematics. And when we study about both the forces causing the liquid to move and as well as the behavior of the particles, the part is called as fluid dynamics. So basically, the fluid mechanics or the concepts of all the involving in the fluid mechanics consisting of or the based on the 5 principles which are called as conservation of linear momentum, conservation of angular momentum, conservation of energy, and conservation of mass, and the conservation of thermodynamics. So basically, these are all the 5 common principles for which we apply in the concepts or in the analysis of the fluid mechanics. So let us see about the characteristics which describe about the behavior or as well as the properties, we can say that. So basically, a liquid is the one in which is very difficult to compress, and hence it may be called as simple as it is incompressible. All the liquids are incompressible for our practical considerations. So it is the one in which it occupies a fixed volume upon the given volume of the container, provided if the volume has been completely occupied within the given space of the container, or else it may form a free surface if the liquid is of the lesser volume and the volume of the object is more than the volume of the liquid. So that is the basic property of a liquid. Then coming to the gases, it is very comparatively easy to compress compared to liquids, and also the changes of volume under the experience of the pressure are very, very large and cannot be neglected. So here, if you are going to consider about the gases, it has no fixed volume and it will expand continuously, restrained by a container, by a vessel. So it will, what we can simple word say, it says that gases occupies the entire volume of the container, whether it is a small or whether it is a large. But whereas in the case of the liquid particles, it will occupy the free volume of the container, provided depending upon the size of the container. So here, if you are going to see, as we have discussed it, that if the volume of the liquid is smaller than that of the volume of the object, it will form a free surface that we can see in the figure. But on the right hand side, you can see a gaseous substance where it can occupy the entire volume irrespective of the size of the container. So here we can see very clearly that gaseous particles are going to diffuse as the container is not having any closed surface. But if the container is having a closed surface, then all the gaseous particles will be distributed within the given container. So that is the basic difference between the liquids and gases. But of course, coming to this fluid mechanics part, basically we are confined to the liquids under its behavior, whether it is at the rest or at the motion. And also we are going to discuss a few examples of the open channels also. So here, if you are going to see the basic examples of the distribution of the bonds with respect to the solids, liquids, and as well as the gases. First, if you are going to consider about the solids, here we can say the order or the arrangement of the molecules within the given object volume is very finite and as well as very fixed, and we can see these are arranged in a very particular manner. Means all these particles will be having a higher bond strength. Coming to the liquids, which is at the middle, we can say that the range order or the bonds are going to be dispersed. And coming to the gases, highly disordered, where it can occupy the complete container volume. But here the common point in all the cases which we can observe is that the volume of the object is the same as for considering both liquids, gases, and as well as the solids. But here we can see the arrangement of the particles is going to be vary with respect to the fluids and as well as the solids. Here we can see some of the examples which describes about the solids and as well as which describes about the liquids, or simply called as fluids. Again, which can be defined again, as we know that the fluids are classified into liquids and gases. So here we can see the number of examples, the common examples which we can come from our day-to-day life. And coming to the application part of the fluid mechanics, here where we can show, as we had discussed about the behavior of the liquid particles, whether at the rest position or moving position, here we can see in all the cases there will be a fluid that is which is of again liquids and as well as the gases are going to be behaved. So, for example, if you are going to see about the natural flows and the weather, here we can say that it may be an open channel flow where the flow might be an steady flow or unsteady flow, and as since it is a natural channel, it may be an the cross-sectional properties are going to be varied. So all these things that comes under the category of an open channel hydraulics. And coming to the wind turbines, as the blades or the wings of the turbine are surrounded by the air that is called as in gases, it will experience some pressure, and accordingly the wings has to be designed. So that is also an application of our fluid mechanics. Then power plants, again here also we can see the smoke that is coming out of the chimneys is going to be dispersed in the air, and hence again we can see the application of the fluid mechanics there, how to design the chimneys and all. Next, piping and plumbing system, which is a very, very common thing which we can see from our day-to-day life. But here, comparatively to all other three examples which we had considered, the last one, the piping and plumbing system, is the thing which we can see from our day-to-day life. Daily households activities, we can come across all these things. Again, in this case, the fluid flows under the action of the pressure, as we are going to give the electrical supply with the help of the pump. So automatically the behavior of the liquid particles in a closed pipe is going to be different. Some more examples are in the boats, because the boat which is floating on the water surface is experiencing the pressure due to the water, and it has to be designed for withstanding of those pressures and all. And aircraft and spacecraft, again this object is completely occupied by the air, which is considered as a gases. And human body, the liquid that is flowing in our human body, that is blood, is also comes under the application of the fluid mechanics. And cars are also going to be designed under the application of the fluid mechanics. So here we can see a very vast number of the applications of our fluid mechanics, confined not confining to any of the particular stream.
Like, share and subscribe. Hit the bell icon for more updates.